Today we're covering line plots. So the main idea is to display and analyze data using a line plot. So a line plot is kind of the start of this whole statistics chapter, where we're going to be going through a lot of different ways of graphing in terms of line graph, bar graph, line plot, histograms, things like that. So we're getting into a statistics area where it deals with a lot of data, typically on a table. And a line plot is one of those forms. Four other terms we're going to be going over in one moment here are cluster, outlier, range, and gaps. And data is typically something we do analyze. So analyze is in there as it is in our main idea. So for cluster. So a cluster is going to be data that is grouped together. So data that are actually grouped together because it's a plural group of data. So say a bunch of data off of a table that are grouped together. Then we have the opposite of cluster, which would be an outlier. Outlier is going to be something that lies on the outside, meaning it's going to be kind of a point that is away from the rest of the group. So we'll say that by saying data that is separated from the rest of the data. Next, we're going to have gaps. So a gap, of course, is typically when there is a lack of data, right? You might have data here, and then we're going to have a space with no data, and then data after it. So that's where a gap is. This particularly is going to be the gap. Lastly, we have range. Range is going to be the main thing we are using in terms of calculating, because this is where we take the highest value, known as the max, and subtract the minimum from it to find what the range of our numbers are covering. And that's supposed to be max. Another term for range would be scope, but you won't see that as often. It'll just be called the range. So the scope of how much points we are covering. So we're going to show you a line plot right here. So we have a table up top. And we've got points. We want to look at our data first before we start doing the line plot. We've got 5, 12, 11, 10, 11, 13, 12, 10. Just looking at it again now, 12, 8, 16. So I see a high of 16 so far, and I see a low of 5. So I'm going to want to have my lowest point be right around 5. We'll say this is 5. One more after, it'll be 4. Then we're going to count up here. We got 10, 15, that'll be our 16. And go a couple more, cut our arrow a little short because we don't need the rest of that. And now, to do a line plot, we just take each point and put an X above it. So I see a 5 here. I'll put an X above the 5. 12, 10, 11, 12, we'll put an X above that. We want to try to keep them level, so if I see multiple, say 11s, I'll put an X above that, and that would tell me that the highest X is going to be above the number that has the most frequently shown up. So right now I put the X on top of the first X because that's my second 11. On to 13, put an X above my 13. 12, X above my first X. 2 10s in a row. And then another 13, another 12, 8, 16, 12, and 11. So now my data is complete. Now I just have to identify clusters. So starting with clusters first. See, for cluster, I see that from about 8 to about 13 is where the bulk of my data is. So that's where the data is all grouped together. So I will call that 8 to 13 as my cluster. Then we'll use green for gap. This is where I have a little space between data. I could say right here, between 5 and 8, we have a little gap. So this is 6 to 7. I also have a little gap at 14 to 15. Since we aren't covering a large range, we'll do it that way. Lastly, we've got range, and actually we're missing one other piece. We'll do outliers next. Range is going to take my biggest point here, which is 16. That's my maximum. And we're going to subtract my smallest point here, which is 5. 16 minus 5 gives us 11. So our range is telling us that we cover 11 points of data over our table. And lastly, outlier is going to be points on the outside. So in this one, 16 is going to be an outlier, as well as 5 because it's outside of our clusters. So we'll say 5 and 16 are 2 outliers. First problem here is using a plot to analyze data. So the climate is telling us a line plot shows number of inches of precipitation that fell in several cities west of the Mississippi River during a recent year. Identify any clusters, so C for clusters, gaps, outliers, and then the range. So we're going to do clusters first. Again, this is a little flexible based on personal interpretation, but I see here from 9 to about 18 is a nice cluster. So we'll put that down, 9 to 18. Also have kind of a little cluster here between 23 and 27. You notice there was a little space between those, but another 4 points that are relatively close together. So I could also say that 32 to 35 is another cluster. Then I just see kind of 2 points here, a point there, another point there. So the rest of it seems like it's not in cluster. Now going with green for gaps second, because now I'm going to find, maybe spaces between clusters that are open. So right here, I see between 19 and 22, there's nothing. Also right at the beginning here, between 6 and 8. So we're going to start with 6 and 8. Then 19 to 22 is another gap. Now again, between my black here, I've got 28 through 31 is empty. And then kind of right here at the end between these 2 points, there's a little gap of 3. So that would be 47, because there's a point at 46, so I can't use 46, and 49. And then I have outliers. Those are my points on the outside. Again, since they aren't in a cluster, we're going to have 2 of them. My first one's 5. Second one is 50. And my range actually involves these 2 because 50 is my maximum. So we write that first. Then we're subtracting our minimum, which is 5. The lowest point that has point on the line plot. So 50 minus 5 will give us 45. Our next question is going to be describe how the range would change if an additional data value of 50 was added. So as you notice here, going back, we had 1.5 here, 150 there, and then we have 2 here. So if we add another 50, would our range change? Our range is still going to be 50 minus 5, because this is still our maximum, even though there's 2 of them, still going to be our maximum, and 5 is still our minimum, so we're still going to get 45, meaning range does not change. So I'll just put range, either range doesn't change or just write simply no change. That'd be all you need, no change. Now if it increased a couple or decreased a couple, you would want to mention that. The line plot below shows the ages of students in an introductory computer course at a local community college. Identify the clusters, gaps, and outliers of data, and identify the range of the data. So, again, we've got clusters, range, gaps, and outliers. So, in this table, see that we've got a lot of data from here to here. That's like a bulk of our data. Everything but 1 is between the numbers 18 and 30. Again, that's how I see it. Someone might say maybe between 18 and 27, and there might be a little gap there between 27 and 30. It depends on how your interpretation is. It is a little loose, a little flexible. So then my gap's going to be from after 30 all the way to 43 over here. So 31 to 43. So why would I go over here from 17 and on? Would I go over there? No, because there's no more data over here. So that's just saying that our number line continues to go, because of course the number line goes infinitely to the right and infinitely to the left. However, with no data there, the only gap is going to be between 31 and 43. Our outlier is going to be 44, because there's no points near it. We're only going to have one outlier, because over here, the other end, that's part of our cluster, so that is not an outlier. You can't have an outlier also be a part of a cluster. Lastly, our range, which we are still going to use what I circled in blue here, so I'll actually recircle it in red, that's right at 18. 18 is our minimum, 44 is our maximum. 44 minus 18 will give me 26, so my range covers 26 points. This next one, we're just going to go on to the last question here. This line plot shows the number of words typed per minute for different people. We aren't going to do the clusters, gaps, outliers, and range because we've done that a couple times already. So we're going to focus on what percent of people type faster than 35 words per minute. So this is part of analyzing our data. We got to find out the percent of people who type faster than 35 words per minute. So we're looking for everything greater than 35 compared to our total, right? Because we got to find our percent is going to take part over the whole. Whole is going to be our total. In this case, greater than 35, I see 3 there, 4, 5, 6 over here. So I have 6 people type faster than 30. And then I see I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 others. So 14 plus 6 will give me 20 total people who did this typing test. So to find the percent, I'm actually going to multiply by 5 because 20 goes evenly into 100. So I'll have 30 over 100. And now I can just switch that right into a percent because any number over 100 equals that number as a percent. N over 100 equals n percent. So that was our last question for the day. If you have any other examples you need done for you, look up personal tutors on our Moodle website, and that'll give you some assistance.